Hello everyone. Today I'm going to discuss about the nomenclature of the coordination compounds. In this, the coordination compounds we are using is basically mononucleotide. So what is mononuclear coordination compounds? Mononuclear. It means coordination compound that contains single metal atom. The nomenclature is basically based on additive principle. Additive principle is when central metal atom is surrounded with ligands. Like this way you can see the structure. So when the metal is surrounded with the different types of ligands, we are calling it as additive principle. Now, this nomenclature basically includes formula writing, and the second one is naming of coordination complex. Okay, let's start quickly. The first part, that is the formula writing. In formula writing, when we write, we always write metal first and ligand should be last in coordination sphere. This point you please remember. Now, we know that coordination compound is comprised of counterion and coordination sphere. Let's look at one example. K4 FeCN6. Now in this case, this potassium behave as counter cation and this FeCN6 behave as complex anion. This is, we also call it as coordination sphere. So how we know which one is cation and which one is anion? When you dissolve this salt in water, it will dissociate as 4K plus and FeCN6 4 minus. Okay. Yeah. So let's start quickly the rules that help in writing the formula. So the rule number 1. As per rule number 1, it says that cation should be named first if the coordination compound contains both counter ion and coordination sphere. So whether that cation belongs to counter ion or it belongs to the coordination sphere, we always write cation when we are writing the formula. Now look at the example. So in this example, K4 FeCN6. So this behave as cation and this behave as complex anion. Another example, CONH3 whole 6 Cl3. So in this case, this cobalt complex will behave as cation and this chlorine, it behave as anion. I'm also calling it as counter anion. Now, please note this. For neutral complexes, this rule we won't follow. It means what? For neutral complexes, like nickel 4, okay, we directly write metal and then ligand. There is no ion concept here. Now the rule number 2. How to write coordination sphere. So this rule helps basically in writing the coordination sphere by using the following points. Point number 1. Use only square brackets. Second point is metal positioned first and ligand positioned last. Third point, no gap between metal and ligands. And for charged or ionic coordination sphere, charge should be indicated outside the square brackets. as superscript. So based on these following points, we can write the coordination sphere. So whenever we are writing the coordination sphere, we should use square bracket. In that we write first the metal and then the ligand. Okay. Now based on this, some examples we are going to discuss. Example first one is FeCN6 4 minus. Now this is an example here. We are writing this ion as first just after when we are starting the coordination sphere. Coordination sphere always should be enclosed in square brackets. First metal we should write, then we write the ligand, and if the ligands are more in number, we use small bracket, and after that bracket we are writing the number in how many number it is present. Then we are closing the square bracket and we are indicating the charge. Okay. So this, because it is carries negative charge, so we are calling it as anionic complex. Another example. In this, it carries positive charge, so we are calling it as cationic complex. And in this complex, no charge is there, so it is neutral. Because it contains no charge. Okay. Now the rule number 3. This rule 3 helps in writing the ligands in the coordination sphere. Okay. So there are some points that we have to remember when we are writing the ligands in the coordination sphere. We are writing the ligands. The first point is ligands with monodentate or polydentate always arrange in alphabetical order in coordination sphere. Point number 2, for abbreviated ligands, the first letter of the abbreviation is used to determine the position of the ligand in alphabetical order. Example, ethylene diamine. So this ethylene diamine is a bidentate ligand, and we use abbreviation EN. Okay, so this E helps in determining its alphabetical order. Another point, when same type of ligand is present in more number, prefix should be used. So for monodentate ligands, we use prefix like bi for 2, tri for 3, tetra for 4, penta for 5, etc. These bi, tri, tetra, penta, these are numerical prefixes that help in writing the number of molecules of the ligands. Now for polydentate ligands, we won't use these prefixes that we are using in monodentate. The prefixes that we are using is bis for 2, tris for 3, tetrakis for 4, pentakis for 5, like that. Okay, just look at the example. If it is written like this, bichlorido, it means 2 molecules of chloride ion is present. Okay, so we won't indicate the charge, we are simply writing here Cl whole twice. Similar, so this is the case for the monodentate. Now for the bidentate or polydentate, for example ethylene diamine, we are using with the prefix bis. So bis ethylene diamine means what? That 2 molecules of En. En is abbreviation, we are using it. So 2 molecules of En is present, and whenever we are writing, we have to write in small bracket, at whole we are doing 2, right? For this, I'm just giving you a note that you should keep in the mind that prefix not used to decide position of ligand in coordination sphere. That prefix not used to determine the position of ligand in coordination sphere. So please understand this part. Here this B, we won't determine the position of the ligand in the coordination sphere with this B, or here bis. It is indicated only by the first letter of the ligand. Okay, so always remember this first letter of the ligand, whether it is monodentate or it is polydentate, that only determines. Now the next point, Polyatomic ligands should be written in parentheses. It means what here? H2O, because it contains more than one atom. So when you are writing about H2O, you have to use small bracket. Parenthesis indicates the small bracket. Another one is NH3. So it is again a polyatomic ligand. So whenever you are writing it, whether it is one in number or many in number, you have to write always in the small bracket. Then abbreviation of the ligands should be written in parentheses. Like for example, ethylene diamine, I represent with EN. So whenever you are writing, you have to write in a small bracket. Similarly, another example, oxalato. So this oxalato group, when you are writing as OX is the abbreviation. So whenever we are using abbreviation in coordination sphere, we have to use under small brackets. And the last rule, Chargeoff cation should be balanced by the charge of anion. Okay, so in this example, I'm giving is K4 FeCN6. So now you look at this thing. This is a complex which has no charge here, but when it dissociate as potassium as cation, and this ion complex with 4 negative charge. So this cation charge should be balanced by the anionic charge. Thank you.